Hey guys, welcome back to chapter 15. So we are going to talk about the last type of equilibrium concentration problems, and y'all, this is the grand finale. These get fun. So what we are going to look at here is we are going to determine equilibrium concentrations, and we're going to determine the value for the equilibrium constant when we know only the initial concentrations. So of all the problems we've done, this is definitely the most realistic. But what you'll find in chemistry is that reality is difficult. Reality can be challenging. Okay. So we're just going to dive right into a problem. We're going to dive in head first and talk about how we would solve it. Okay. So here is our grand finale. Suppose we have a reaction mixture in which the initial concentration of A is 1 molar and the initial concentration of B is 0. The equilibrium constant K is 0.33. Find the equilibrium concentrations. And the one thing that this slide doesn't have on it that it should and that I would always give you is the equation. So the equation is A and 2B. Okay. All right, so we're given the equilibrium constant. So that's something new. We're given the initial concentrations. That's something pretty easy to find out. Now we've got to solve for this right here. Once we solve for that bottom row of boxes, then we'll be finished with this problem. Okay. So what can we fill in? Well, we can use our same logic that we've been using to determine what the change is going to be. So for B, our product, there's only one way. Sorry, guys. There's only one way for B to go, and that's up. Okay. So B is going to change by a factor of X. And don't forget that coefficient. So it's actually going to change by a factor of 2x. Okay. And A, there's only one way for A to go, and that's down. We're going to use up A to make B. So the change here is going to be a negative X. Okay. So if we continue with this process, we don't have any actual numbers to use. The equilibrium concentration for A is going to be 1 minus X. And the equilibrium concentration for B is going to be 2X. Now all we have to do is solve for X. Sounds easy enough. All right. So here's our equation for the equilibrium constant. So concentration of our products over the concentration of our reactants. So I'm going to plug in what I know. I know the concentration at equilibrium of B is going to be 2x. I'm going to square that. And I know the concentration value of A is going to be 1 minus x. Right? And I also know the value for Kc. So if you click back a slide, it tells you that Kc equals, okay, well now we've got something, if we focus our attention right here, now we got something that looks a little bit like some advanced algebra, right? So we can solve for X if we can get that into a format that's a little bit more user-friendly, okay? So the first way that we're going to learn to solve for X is taking it back old school and using the quadratic formula. So I'm going to teach you 3 different ways to solve for this type of problem, the red problem, the grand finale problem. The first way that I'm going to teach you how to solve for these is using the quadratic formula. Okay. way back. I know, taking it way back. So the quadratic formula looks something like this. So we're going to get this guy into a format that looks like this. So we're going to have 0 on one side. We're going to group all of our numbers that have an x squared. We're going to group them all together. We're going to group all the numbers that have the variable x together. And we're going to group all the numbers that don't have x together. And then we'll have an a and a b and a c that we can plug into a quadratic equation finder. Okay? So now we need to rearrange this guy to look like that. All right, so let's do some algebra here. So the first thing I'm going to do is I'm going to get rid of the bottom part of this fraction. So I'm going to multiply by 1.0 minus x. So that's on top, that's on bottom, that cancels. Whatever I do to the left side, I have to also do to the right side. Okay? So that leaves me with 4x squared. And now I need to distribute this through. So 1 times 0.33 is just 0.33. And x times 0.33 is going to be minus 0.33x. Okay. Well, now we don't have any fractions, so that's good. Now we need to make it look like this, where we have 0 on one side and everything else on the other side. So I'm actually going to move these variables over to the left. It doesn't matter which way you move them. You just got to move them one way or the other. So to do that, I'm going to subtract by 0.33. Actually, no, let me do the other one first. I'm going to add by 0.33x. So those cancel. I'm going to add 0.33x. So over here, I've got 4x squared plus 0.33x equals 0.33. And then to get this guy moved over, I'm going to subtract by 0.33. Those cancel. Subtract by 0.33. So I'm just going to clean it up right here because I'm running out of room. So minus 0.33 equals 0. Okay. Now we've got a format that looks like this quadratic equation, where this is our a value, this is our b value, and this is our c. So a equals 4. B equals 0.33, and C equals negative 0.33. Okay. And from here, what I would do is I would just Google quadratic formula calculator. You can put it into your actual calculator. So you have like a TI-84 or 83. There's a way to put in the quadratic formula into your calculator. But at this point, I wouldn't try to solve for the quadratic equation. I would just let a computer do the work for you. If you like to torture yourself, so here's just the rearrangement. If you would like to torture yourself, here is the quadratic formula. So you could plug in B and B and A and C and A and math it out. That's fine. Or let the quadratic equation do it for you, or calculator do it for you. So when you plug this into the quadratic formula, it's always going to spit out two numbers. So looking at the quadratic formula, we see this plus and we see this minus. So we're going to take one path where we take negative b plus, blah, blah, blah. And we're going to take another path where we take negative b minus, blah, blah, blah. So it's always going to spit out two values for x. But x, for us, one of the x values is not going to make sense. So let's think back, what is x? What does x mean to us? Remember the X is our change. So X is how much the concentration of our products or reactants are changing. So does it make sense to have a negative value? Well, no. B can't change by a negative 0.33, right? That doesn't make any sense. So change can't be a negative number. So in this case, the change has to be a positive number. So the only X that makes sense for us is the 0.249. So that's the one we're going to use. Okay. So if X equals 0.249, make sure I got that right, being dyslexic. Yep. Now, if I want to solve for these values at equilibrium, I just plug in the 0.249 here. I plug in the 0.249 here, and I math it out. So 1 minus 0.249 equals, so the concentration of A at equilibrium is 0.751, and the concentration of B at equilibrium, so I'm going to take 2 times 0.249 is 0.498. And remember, concentration is a molarity, so molar. Okay. So just to summarize, what did we do? We knew the initial concentrations. We knew the value for K, so the equilibrium constant. We used our ICE table. So we had to put X's into our ICE table and then use algebra to solve for X. In this case, the algebra was the quadratic formula. Once we use the quadratic formula to solve for X, then we come back and we plug in X to determine equilibrium concentrations. I hope you guys found this helpful.